How does MongoDB sharding work? If you have ever wondered how MongoDB manages to handle massive amounts of data efficiently, you are in the right place. Today, we will break down the concept of sharding in MongoDB and how it plays a vital role in data science and analytics trends, especially in big data processing. So, what exactly is sharding? In simple terms, sharding is a method that allows MongoDB to scale horizontally by distributing data across multiple servers, which are known as shards. This method helps manage large datasets and high volumes of user requests by spreading the workload across several machines. A MongoDB sharded cluster consists of three main components. First, we have the shards themselves. Each shard is an independent MongoDB instance or a replica set that holds a subset of the total data. By dividing the dataset into smaller parts, all the shards together store the entire data. The replica sets within these shards provide redundancy and ensure high availability. Next, we have the query routers, which are often referred to as Mongos. These act as intermediaries between client applications and the sharded cluster. When an application sends a query, the Mongo's instance determines which shard or shards contain the relevant data. It does this by consulting metadata and routing the query accordingly. If necessary, it aggregates results from multiple shards and returns them to the client. This routing process is seamless for the application, meaning no changes are needed on the client side. The third component is the config servers. These servers store metadata about the cluster's structure, including how data chunks are mapped to shards. Config servers maintain the cluster's configuration and ensure that routing information remains consistent. They are also deployed as replica sets for added fault tolerance. Now, how does the sharding process work? It involves partitioning data into chunks based on a shard key. This key is a specific field or set of fields chosen to distribute data evenly across the shards. MongoDB automatically balances these chunks to maintain an even distribution of data and workload. When new data is added, the balancer redistributes chunks as needed to prevent any shard from becoming overloaded. From a broader perspective, MongoDB sharding effectively addresses the challenges of scaling databases horizontally in big data environments. It supports increasing data volumes and user concurrency without sacrificing performance or availability. This makes it an excellent choice for modern applications that requiring scalable distributed data storage, such as real-time analytics, Internet of Things platforms, and large-scale web services. In essence, MongoDB sharding works by breaking down a large dataset into smaller, manageable pieces that are stored across multiple servers. Query routers direct requests to the appropriate shards based on the metadata stored in config servers. This architecture allows for efficient handling of large-scale data and high traffic, aligning perfectly with current trends in big data processing and distributed computing.